Hello everyone, my name is Jie. So you are watching my video to show how I plan to use manipulatives to help students better understand the Pythagorean Theorem. So instead of directly teaching students the definition and equation, I plan to use a couple of hands-on activities to help students to figure out the definition and the equation by themselves, step by step. So here is the first activity I plan to do at the beginning of the class. So each group is going to receive a worksheet exactly like this. So students are asked to figure out which route is the shortest between A, B, and C. Okay, so the reason I plan to use this activity is because I want to activate students' prior knowledge and also to build a connection between what they already know and what we're going to learn in the present lesson. So the second activity we're going to do is, after students figure out the shortest distance between the 2 points is a straight line, I'm going to ask them one more question, whether they can figure out how long the shortest distance is. So if they know the length of one side and the length of the other side, and they also know this is a right triangle, whether they can figure out the distance here. Okay, so students are going to have 30 seconds to talk about it. After that, I will suggest them they can use a ruler to get the measurements. So after they use a ruler, okay, they will get 3 numbers, right? So they're asked to write down the 3 measurements on their handout, on the worksheets. So it's going to look like this. So 3, 4, and 5. Then I'm going to ask them whether they can come up with an equation in which they can include all the 3 numbers. So students are going to have another 1 minute to talk about it. After that, instead of directly giving them the equation a squared plus b squared is equal to c squared, I'm going to let them work on a handout activity to help them figure out the equation by themselves. So this is how I plan to do. Each group is going to receive a zipper bag like this. When they open the zipper bag, they're going to see 4 pieces of pre-cut sheets. So 1 triangle, okay, and 3 squares of the different sides. So the first thing I want my students to do is to put the triangle in the middle of their table. And then for the 3 squares, each square has the same length of the side as one side of the triangle. So they're going to find the match. So I'm going to use the smallest square as an example. So see, here is not a match here, but here is a great match. So students are going to follow my example to figure out a match for the other 2 squares. So this is how they look like. Okay, so now the thing is, the second question I'm going to ask students to answer is, okay, since they already find the match, find how to position the 3 squares, I'm going to ask them whether they will be able to find the areas of every single squares. Since here I'm going to use the yellow square as example 2. So since this is A, so for the yellow square, the area is A square. For the blue one, the medium sized one is B square. For the largest one is C square. So next thing they're going to do is to cut the medium sized square along the lines. Okay, so I already cut it in order to save time. So this is how it looks like. Okay, And then they're going to play, students are asked to play with the smallest square and also the 4 pieces of the medium size square. See whether when they play with the 5 pieces, see whether they can fit everything inside the big square, just like a puzzle. So this is how it's supposed to look like when they finish the activity. Yes. So after they have the activity done, so I'm going to ask them to discuss in group about their experience. So they're going to answer several questions. So the first question is, what did they do during the activity? The second question will be, what did they discover? So the answer will probably be like this. Oh yes, we played with the 5 pieces of sheets and then they can fit together inside the biggest square, just like a puzzle. Yeah, that's what they achieved. That's what their discovery is, right? And then the third question would be, whether can you come up with an equation to represent your discovery? So I will remind students, remember, you figure out the squares, the areas of the 3 squares. So the smallest one, remember, is a square. So for the 4 pieces of the blue square, the medium size square, so it's b square. Remember, when you put the 4 pieces together, it's a medium size square, so it's b square. Since you fit everything, all the 5 pieces inside the biggest square, just like a puzzle, right? So it has the same area. So this is the equation they come up with from working on the activity, right? This is exactly the equation of Pythagorean Theorem. And then I'm going to guide them to figure out the definition, how to describe this equation by using mathematical vocabulary. So I'm going to write the sentence stamp on the whiteboard and ask the students to discuss and fill in the blanks. So here is how it's supposed to look like at the end. So the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So after students come up with the equation, the definition, so I'm going to show students how to apply this Pythagorean theorem and its inverse to solve problems. So this is how I plan to teach the Pythagorean theorems. So what I like most about this lesson plan is, instead of like the teacher directly feeds students the knowledge, so students come up with equation and the definition by themselves by working on hands-on activities. And I believe students will have a better understanding about the Pythagorean theorem by working on activities. So, thanks for watching.